Hello students, this is Mrs. Raposa. I will be presenting your lesson on section 7.1, measurements of angles. In this lesson we'll be learning how to convert angles back and forth from degrees to radians, and we'll also find out what the meaning of coterminal angles and to find coterminal angles. So first of all, let's start by saying that angles can be measured in different units: revolutions, degrees, or radians. Just like lengths can be measured in inches, meters, feet, there's different units for angle measures as well. One revolution is known as 360 degrees. Now I put the word degrees there, but you also know this symbol to mean degrees. And 360 degrees is the same thing as 2 pi radians, and 2 times pi is 2 times 3.14 about, so it's approximately 6.28 radians. Before I go any further, I'm going to have you sketch in the corner of your paper what we call the unit circle. And so I'll make an x-axis and a y-axis, and I'll draw the unit circle. And the unit circle has as its center, so I'll put over here, this is what the unit circle is. You'll learn more about the unit circle in section 7.2. But on the unit circle, the center is 0, 0, and the radius is 1 unit. And that's why it's called the unit circle. It's a 1 unit circle. 1 full revolution is 360 degrees, and you can also think of that as 2 pi radians. The nice thing about degrees is that degrees is in whole numbers usually. When you divide it by 9, 3, 6, it's divisible by a lot of numbers, and you still get nice, pretty whole numbers. 2 pi is a messy decimal because pi is an irrational number. So it's not going to be a pretty angle measurement. And we'll talk about when you can put angle measures for radians in terms of pi and when to use decimal approximations. Well, if 360 degrees is 1 full revolution, then 180 degrees is a half of a revolution. Cut it in half. And 180 degrees is equivalent to 1 pi radians. Cut 2 pi in half, so about 3.14 radians. Positive angle measures are angle measures that move counterclockwise. One way to think of it is as the way the sun rises and sets. So if you think of this as maybe the equator of the Earth, this unit circle, think of it as the Earth, the sun is going to rise in the east, and as it rises in the east, it moves counterclockwise and sets in the west. And if the unit circle is centered at 0, 0, and I can use this as the point 0, 0, every angle has 2 rays, and one of the rays is going to be where it starts, the initial ray. So the angle starts here, and maybe it moves 30 degrees. Then it ends at some place over here, and that would be our terminal ray. So every angle is going to have an initial ray and a terminal ray. In trigonometry, we usually say that the initial ray is on the x-axis, and this would be the point 0, 0, but not always. Negative angle measures, then, are going to move clockwise. And again, this would be the initial ray, and this would be the terminal ray. Okay, I just want to mention that this symbol you see here, it represents the angle measure, how many degrees or how many radians we're moving the initial ray to get to the terminal ray. So theta, it's a Greek symbol, looks like a circle with a line through it. That stands for the angle measure. Okay, now let's talk about how to convert angle measures back and forth from radians to degrees or from degrees to radians. Well, you already know that 180 degrees converts to pi radians, and 360 degrees is the same thing as 2 pi radians. Let's convert these angle measures into radian angle measures. I put some conversion strategies up here. If you want to go from degrees to radians, then you just take the number of degrees and you multiply it by this fraction, pi over 180. So I'm going to do that. 30 degrees, that's the number of degrees, multiplied by pi over 180. And that will give me 30 1/80ths of pi, 30 pi over 180. And that will reduce to 3/18 which is 1/6 of pi, or pi over 6 radians. And I like to think of it this way. 30 degrees is 180 degrees divided by 6. So this is pi radians divided by 6. Notice that if it's an angle measure in degrees, it'll have a degree symbol there. If it doesn't have a degree symbol, even if it's a whole number, like 20, assume it's in radians and not in degrees. So let's convert negative 45 degrees. Now this is an angle measure that moves counterclockwise. This is an angle measure that's going to move clockwise. So again, I'm going to multiply it by pi over 180, put the 45 over 1, and that'll give me negative 45 over 180 degrees, and 45 and 180 are both divisible by 45. So divide negative 45 by 45, you're going to get negative pi, and divide this by 45 degrees, and you're going to get 4. So this is the same thing as negative pi over 4. So negative pi would be a half of a rotation clockwise. Divided into 4 units, this is 1/4 of pi, 2/4 of pi, or 1/2, 3/4, 1 full pi radians. Remember, pi radians is a half a rotation. So it's basically 180 degrees divided by 4, moving clockwise. Negative 300 degrees, converting that to radians, I'm going to multiply it by pi over 180. Again, put this over 1, and I'll have negative 300 pi over 180, which will give me negative 30 pi over 18, and negative 30 and 18 are both divisible by 6, so that will give me negative 5 pi over 3 when you divide 30 and 18 by 6. So it'll be negative 300 degrees is equivalent to negative 5 pi over 3 radians. 120 degrees multiplied by pi over 180, that will give me 12/18 when I divide them both by 10, 12/18 of pi, divide 12 and 18 by 6, and I will get 2 pi over 3, and it's a positive angle measurement. So 2 pi over 3 is the same thing as 120 degrees. These were all multiples of either 30 or 45 degrees. Usually when the angle measures are in multiples of 30 degrees or 45 degrees, I keep them in terms of pi instead of turning them into decimal approximations. Like you could plug this into the calculator, 3.14 divided by 4, make it negative, and you're going to get a messy decimal. For the angle measures like this, sometimes it's easier to just put them in decimal approximation form. So again, you can go to your calculator and do negative 205 degrees, and then multiply that by pi over 180, and it will give you the decimal that's approximately negative 3.578. So negative 205 degrees is going to be about negative 3.578 radians. And again, this is certainly a messy one. So again, just multiply it by pi over 180. Go to your calculator. You'll do 311 times pi divided by 180, and that will give you about 5.428 radians. So it's okay to leave these as decimal approximations, and I'm going to put approximately equal to, and these as, because they're multiples of 30 or 45 degrees, these angle measures, A through D, I'm going to leave them in terms of pi. Okay, let's go to example 2, where this time we have to go from an angle measure that's in radians, because I don't see a degree symbol, and convert it to degrees. And to go from radians to degrees, I'm going to multiply the number of radians by the reciprocal of this, 180 over pi. I remember I want to put it into degrees. Notice how the degree conversion is on top, the one that's on top. And if I'm going from degrees to radians and I want to put it into radians, this is what I want. I want something in terms of pi when I'm going to radians. But anyway, let's convert this to degrees by multiplying it by 180 over pi. And the pi's will cancel, and this reduces to 180 divided by 3, so it's equal to 60 degrees. So pi over 3 radians is equivalent to 60 degrees. 7 pi over 3, when you multiply that by 180 over pi, again, the pi's are going to cancel, And I like to do the division first. 180 degrees divided by 3, that's 60 degrees. So do the division first. It's easier to go to a smaller number and then multiply by 7 to get the bigger number. So 180 degrees divided by 3 is 60 degrees. And 60 times 7 is 6 times 7 times 10, so 420 degrees. Notice that this is more than one full revolution. This is more than 360 degrees. Sometimes that happens. Sometimes it's a positive angle measure, so I go 360 and a little bit more. So negative 5 pi over 6, I'm going to multiply it by 180 over pi. The pi's will cancel. 180 degrees divided by 6 is 30 degrees. Get the smaller number first. 30 degrees times 5, 150 degrees. Actually, it's negative 150 degrees because it is a negative angle measurement. And last but not least, 9 pi over 4. I kind of do it this way. Pi, radians, is 3.14 radians. Same thing as 180 degrees. So think of this as 180 degrees divided by 4, which is 45 degrees, and that'll be 45 times 9. So basically, again, I could do the same thing. Multiply it by 180 over pi. Pi's cancel. 180 degrees divided by 4 is 45, and 45 degrees times 9 is 405 degrees. Again, more than one full revolution. And that's how you convert angle measures from radians to degrees. Okay, worth noting is that your calculator even knows that you need to differentiate between angle measures and radians or degrees. If you hit the mode button and you scroll down to where it says radians or degrees, most graphing calculators come preset to work in radians. You can scroll right, hit enter. If you want to work with degrees, scroll back, hit enter, and change it to radians back and forth. That will come in handy for section 7 too. Okay, as tiny as one little degree is, not much of a movement. If you start here and move 1 degree, you're not going to move very far. Each one of those degrees can be broken up into 60 parts, called a minute. So 1 degree is equal to 60 minutes, just like an hour is equal to 60 minutes. And each one of those tiny little minutes, 1/60th of a degree, can be broken up into 60 parts, called a second. So there's 3,600 seconds in a degree, just like there's 3,600 seconds in an hour, and there's 60 minutes in a degree, just like there's 60 minutes in an hour. So that means that 1/60th of a degree is equal to a minute, and 1/3600th of a degree is equal to 1 second. So for example 3, we're asked to convert 12.3 degrees into something with minutes and seconds in it. But it's a little tricky because this is 12.3 degrees. 0.3 degrees is not a minute. That's 3/10ths of a degree. So this is 12 degrees and 3/10ths of a degree, not 3/60ths of a degree. So to do that, what we're going to do is we'll do 12 degrees and we'll add it to 3/10ths or 0.3 times 60 minutes. And that will give me 12 degrees and add it to 18 minutes. So 12 degrees and 18 minutes. And the notation we use for minutes are these little, looks like little apostrophes, right? So 12 degrees and 18 minutes. 1/ for minutes, 2/ for seconds. So let's go the other way. Let's go from decimal approximation for degrees. That's what we did here, into minutes and seconds. Now let's go from 25 degrees, 20 minutes, and 6 seconds into something with decimal approximations, going the other way. So 25 degrees, we'll add that to 20 minutes, but 20 minutes is really 20/60ths of a degree. Each one of those is 1/60th of a degree, and 20 times 1/60th is 20/60ths. Plus, this is how many 3600ths of a second we have. So 6 over 3600. And you can just crunch that into your calculator, and you'll get, when you add those two fractions to 25 degrees, you'll get about 25.335 degrees. Okay, recall that the perimeter of a circle is called its circumference. And I can take a look at just a piece of that circumference, or a fraction of the circumference. created by some central angle theta. If theta is 30 degrees, then this will just be a fraction of that whole circumference, or a piece of the circumference. Radians are based on the length of the arc, or the radius, you could say, on the unit circle. Remember that the unit circle has a radius equal to 1. You'll learn later in the next section that the formula for arc length, S, is the radius times the angle measure, theta, if the angle measure is in radians. On the unit circle, where the radius is 1, the arc length, or the length of this piece of the circumference, will just be 1 times the angle measure in radians, which means that this angle measure will give us the length of the arc, but that's only on the unit circle, where the radius is 1. Okay, so let's take a look at example 5. This formula and example 5 are really a little bit of a sneak preview into section 7.2, but we'll go ahead and do them. They're pretty simple. So remember that this formula is only used for arc length if you're given the angle measure in radians. You cannot use this formula if it's in degrees, so not an angle measure in degrees. That's important. You would use another formula for that. So, for example 5, give the radian angle measure of theta if the arc length is 7. Now S stands for the arc length. So I'll use this formula that arc length S is equal to the length of the radius times the angle measure in radians. And I want to find the angle measure if the arc length S is 7 and the radius R is 4. So I just substitute 7 in for the arc length and 4 in for the radius, and just divide each side by 4, and I will get that 7/4 is equal to the angle measure in radians. So theta is equal to 7/4 radians, and I can put the word radians, but as long as I know that there's no degree symbol, I know we're not talking about degrees. Okay, just to give you a little visual that goes along with this, if the angle measure is 7/4 of a radians, that's 1.75 radians. And I actually drew a picture where the length of the arc on this circle is 7 and the radius is 4. We'll find out what that is in degrees. If I wanted to convert it to degrees, I don't really need to. They didn't ask us to, but just to get a visual of what it really means. 1.75 radians, multiply it by 180 over pi to convert that to degrees. That's about 100.3 degrees, so a little bit better than 90 degrees. So I made an angle measure. That's 1.75 radians, or about 100.3 degrees. And you can get a visual of what that would look like. Okay, before we do example 6, let's first explain what coterminal angles are. Coterminal angles are angles that have the same terminal ray, or you can say they land in the same position. So let's take a look at what I have drawn above here for this diagram. Let's say this is a 60-degree rotation from here to here. That'll land me right here in this spot. 60 degrees lands me here, positive 60 degrees, but so does negative 300 degrees land me in the same spot. So that means that 60 degrees is coterminal with negative 300. So let's take a look at example 6a. First of all, I like to draw the diagram. So a 30-degree rotation is going to land me here, right? 30 degrees. If this is my terminal, my initial ray, and I move this way, I'm going to land right here in this spot. Well, a 30-degree rotation positive means a counterclockwise rotation. I could also go a full 360 degrees if you want to draw the unit circle. That's okay. I could go a full 360 degrees plus another 30 degrees. So let's do 360 degrees plus 30 degrees, and that will give me a 390-degree rotation. Remember what quadrants we're in. Remember, this is quadrant 1 on the quadrant 2, quadrant 3, and quadrant 4. So a 30-degree rotation, if this is my initial ray right on the x-axis, that's going to land me with the terminal ray right here. And that would give me a 30-degree rotation. Well, if I move 360 plus another 30 degrees, then the terminal ray is still in that position. same position. So 390 degrees is coterminal with a 30-degree rotation. A negative angle measure, remember I want to give two angle measures, one positive and one negative. So there's my positive angle measure. To get a negative angle measure, I need to go to figure out how many degrees would I go this way, clockwise, negative angle measure, to land with the terminal ray right here. Well, that would be 360 degrees minus that 30-degree rotation. So back up another 30 degrees. So 360 degrees minus 30 degrees. And that would give me 330 degrees. But remember that this is a negative rotation, so really it's negative 360 plus 30. So a negative rotation of 330 degrees. Okay, for part B, we're given the angle measure negative 3 pi over 4. So it's going to be a clockwise rotation, a negative angle measure. And remember that pi is like pi radians. You can think of it as 180 degrees. So I took this 180 degrees and broke it up into fourths, because it's broken up into fourths. 1/4, 2/4, 3/4, 4/4. This is actually negative 135 degrees. It'll land right here. So the terminal ray will land in this position in quadrant 3. So what other angle measure will land us in this position? Well, let's think of a positive angle measure first. So positive angle measure, again, I took pi, or 180 degrees, and broke it up into fourths. That would give me 1/4 of pi, 2/4 of pi, 3/4 of pi, 4/4, 5/4 of pi, or 5 pi over 4, going counterclockwise. So that's my positive angle measure, 5 pi over 4, or 5/4 of pi. Let's find a negative angle measure, going this way. That would be 1/4 of pi, 2/4 of pi, 3/4 of pi, clockwise, right? But I can add another 2 pi to that. Remember, 2 pi is a full rotation. So what I can do is add a full rotation to this angle measure. But again, I'm going clockwise, so it's a negative 2 pi rotation, and then added to negative 3 pi over 4. Remember, this is going to be a full rotation plus another 3/4 of pi. So that will give me negative 8/4 of pi plus negative 3/4 of pi, negative 8 pi over 4 minus 3 pi over 4, and that will give me negative 11 pi over 4 in radians. So those two angle measures are coterminal with a negative 3 pi over 4 rotation. Okay, our last example, example 7. Find the equivalent number of degrees per minute and the equivalent number of radians per minute of a gear that's revolving at 20 revolutions per minute. So you might want to write down what RPM stands for. Well, one full revolution is equal to 360 degrees. So 20 revolutions per minute is really 20 sets of 360 degrees per minute. And that will give me 7,200 degrees per minute. So we've done the degrees one. Now, remember that one revolution is equal to 360 degrees, but it's also equal to 2 pi radians. So 20 sets of 2 pi is going to be 40 pi radians per minute. So we've converted the degrees, we've converted the revolutions per minute to degrees per minute and radians per minute. So that concludes your lesson on section 7.1. Your homework will be some variation of these problems right here. A lot of these problems have parts A, B, C, and D to them, so that's a lot. So we'll break it down, and your teacher will tell you what your homework is. If you have any questions, contact your teacher, and have a great day, guys.